Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Eirshady Bin Ezzuddin. My metric number is 221042120. I'm from product design. Today I will present about the project which the title is aircraft engine bracket. The overview of the project is number 1, we need to redesign the aircraft engine bracket. Number 2, the design need to achieve certain requirement of the engine bracket. For the last one is do the analysis on the new engine bracket. Next, the objectives. Next, the objective. The objective of this project is to redesign a metal bracket supporting 15,000 Newton, and the mass of the bracket must be below of 0.8 kilogram and need to achieve the factor of safety more than 1.5. And lastly, the max deflection for the bracket must be below than 0.35 mm. Number 2, the objective is to perform finite element analysis FEA in NCs to evaluate von Mises stresses FOS and deformation with mesh size 3.0 mm. Number 3, to analyze multiple bracket designs and identify the optimal design based on structural and performance criteria. The requirement of the engine bracket is as shown on the slide. The mass must be below than 0.8 kilogram. The total deformation can be same or below 0.35, and the factor of safety can be same or above than 1.5. Here is the design. Here is all the design that designed by all the group member. For design number 1, me Eirshady design the bracket. For design number 2, my friend Ikma, and design number 3 is design from Nia. From these 3 design number 1 has been chosen. Why does the design number 1 win? As we can see, for the mass, the bracket have 0.696 kilogram, which is below than 0.8 kilogram. For the factor of safety, the value is 1.7, which is above than the requirement 1.5. For deformation, based on the 3 design, the deformation is not the best from the 3 design, which is the bracket have 0.29 mm for the total deformation. Next, the analysis that we need to do is first, linear static analysis. Linear static analysis is foundational method for predicting the structural response of mechanical components under various static loads. Analysis number 2, thermal stress analysis. What is thermal stress analysis? Thermal stress analysis is to examine the effects of temperature changes on materials and structures. Analysis number 3, Free vibration analysis. Free vibration analysis is to understanding the dynamic behavior of structures like natural frequencies and mode shapes. For linear static analysis, as shown, the figure shown for the maximum total deformation is 0.294, and the figure also shows the color contour of the total deformation. Next, equivalent von Mises stress. The figure shows the color contour of the von Mises stress for the bracket chosen. Next, factor of safety of the bracket. The value of factor of safety is 1.76, and the color contour as shown in the figure. From the result, we can conclude that our design have achieved the targeted value that asked from the project. To do thermal analysis, to do thermal stress analysis, we need to add thermal expansion into material properties, which is 2.36 exponent negative 5 Kelvin. Next, in static structure, we need to add thermal condition. Next, set the environment temperature to 25 degrees Celsius, and also set the magnitude to 600 degrees Celsius. Next, the slide shows color contour of the bracket without thermal expansion and with thermal expansion. For the figure below is without thermal expansion, and for above figure is with thermal expansion. This is color contour for total deformation. The difference color contour for von Mises stress is like the slide show. Next, factor of safety. As we can see, the difference of the color contour shows the difference value of factor of safety for the bracket without thermal and with thermal expansion. Here is the comparison of the result for thermal expansion. Without thermal expansion, the total deformation is 0.294 mm, an equivalent von Mises stress 285.8 megapascal, and factor of safety 1.76. With thermal expansion, the total deformation has increased to 1.99, almost 2 mm. Equivalent von Mises stress also increased to 55 to 6.2 megapascal, and the factor of safety for the bracket with thermal expansion is decreased to 9.1201 exponent negative 2. For the last analysis is free vibration analysis. Maximum value of total deformation for mode 1, 91.152 mm with the frequency 2443.5 Hz. For mode 2, 91.403 mm with the frequency 3949.7 Hz. And for the others mode as shown in the slide. From the result of free vibration analysis, we can conclude that the value of the natural frequency increasing from mode 1 to mode 6, and since the fundamental frequency do not match the structure excitation frequency, the structure was considered to be safe from resonance. In conclusion, Design choice is Eirshady bracket design using 7075T6 aluminum alloy. For the factor of safety, achieve highest factor of safety of 1.06, exceeding minimum requirement of 1.5. Mass lightest among alternatives at 0.69 kg, below maximum allowable mass of 0.8 kg. For deformation, slightly higher deformation 0.294 than others design, but still acceptable because it is below than 0.35 mm. For the future improvement of the bracket, we need to focus on optimizing bracket geometry and exploring advanced materials for further enhancements. The recommendations for the bracket: conduct additional fatigue and thermal studies to ensure long-term reliability under varied operation conditions. For conclusions, Eirshady design offers optimal balance of safety, weight efficiency, and performance for aircraft engine brackets. That's all from me. Thank you very much.